I'm going to show you a second method for solving for the constants when you're doing partial fraction decomposition, because sometimes just letting x equal 0 or 1 or -1 doesn't eliminate many of the terms over on the right hand side. And if you use the second method, sometimes it'll be make your life a little bit easier. So I'm going to give you this example: x cubed minus x squared plus 3x plus 2 all over x squared plus 1 squared, and ask you to find the partial fraction decomposition. If you'd like to shut off the video for a second and just make sure you can set it up yourself, that might be a good idea. Or if you want to just watch me do it, that would be fine too. This is a repeated quadratic unfactorable, so we have ax plus b over x squared plus 1. And then we have cx plus d over x squared plus 1 to the second power. Kind of like what we did in class, except we had another x tacked onto the front, so we had the letter e. So we're going to solve for a, b, c, and d. And we're going to get started just like we always do. Clear the denominators. X cubed minus x squared plus 3x plus 2 is equal to ax plus b times x squared plus 1, because one of them will cancel out. And then this whole denominator will cancel out, so we have cx plus d. And when you take a look at that, you can see that probably if you let x equal 0 or 1, you're still going to end up with a system of equations that will take a little bit of time to solve. It won't be impossible, but there's another method that might make this problem go a little bit quicker. What we're going to do is we're going to FOIL these two binomials. So FOIL, ax times x squared is ax cubed, b times x squared is bx squared, ax times 1 is ax, and b times 1 is b. So that's just the FOIL of that, and then we have a cx plus d. Now what we're going to do is we're going to arrange these terms in almost like standard form, having the x cubes come first, x squares come second. Now we're going to have to move the cx next to the ax, so we're just going to interchange these two terms. Ax cubed plus bx squared plus ax plus cx, those two are like terms, and we're going to actually factor the x out of that, plus b plus d. So if we factor the x out of that, we have ax cubed plus bx squared plus x times a plus c plus b plus d. And that's equal to x cubed minus x squared plus 3x plus 2. Now when you use this second method of equating the coefficients, what that means is you're going to look at the x cubed term on the left and the x cubed term on the right, and this coefficient is 1, this coefficient is a, so we're just going to we're going to solve for a, because this is the only cubic term on the right hand side. A has got to be equal to 1. Well, that was pretty easy. The next thing we're going to do is we're going to let the coefficient of x squared be equal to the coefficient of this x squared. So this b is equal to -1. Well, that was pretty easy, solving for those two. Then the only thing left to do is let this coefficient of x be equal to 3. So this coefficient of x is a plus c. So we can say a plus c is equal to 3. Well, we already know that a is equal to 1, so 1 plus c is equal to 3. So we've got c is equal to 2. Well, that was pretty easy. And then the last thing we're going to do is let this is the constant term, b plus d. b plus d is going to be equal to 2. Whoops, b plus d equals 2. Well, we already know that b is -1, so -1 plus d is equal to 2. So d is equal to 3. Well, that was a lot easier than setting up a whole system of equations, a 4x4 system, to try to solve it that way. So when we have those four constants, you could just plug them into the original problem, and your final answer would be, let's see, a is 1, so you have x minus 1 over x squared plus 1, and c is 2, d is 3, all over x squared plus 1 to the second power. So that wasn't so bad after all, a, b, c, and d. So here's a second example that is pretty similar to the first one, negative x cubed plus 2x squared minus 3x plus 15 all over x squared plus 8 quantity squared. And if you want to try this one yourself, you can, using the same method that I showed you up above, or if you'd just like to go through it with me, that would be fine too. So we're going to set this up like we did before. We have an unfactorable quadratic, so we have ax plus b over x squared plus 8, and then we have a cx plus d all over x squared plus 8 raised to the second power. To clear the denominators, we get negative x cubed plus 2x squared minus 3x plus 15 is equal to ax plus b times x squared plus 8 plus cx plus d. And then we're going to FOIL these and get ax cubed plus bx squared plus 8ax plus 8b plus cx plus d. And then we're going to move the two x terms together, so we're just going to interchange these two. So we have ax to the third plus bx squared plus 8ax plus cx plus 8b plus d. And that's equal to negative x cubed plus 2x squared minus 3x plus 15. And so now to equate the coefficients, you're just going to let a equal negative 1, because this a doesn't have another x cubed term here. So we have a is equal to negative 1. And there's no other x squared term, so we can just have b is equal to 2. And then the next two things we have is 8a plus c is equal to negative 3. Well, we already know a is negative 1, so negative 8 plus c is equal to 3. Well, if you add 8 to both sides, negative 3 plus 8 is 5, so that means c is equal to 5. And then the last thing we have is 8b plus d equals 15. Well, we already know that b is 2, so 16 plus d is equal to 15. That must mean that d is equal to negative 1. This b is 2 can go right there. And so we have them, and that was pretty fast and easy. So the final answer would be negative x plus 2 over x squared plus 8 plus 5x minus 1 over x squared plus 8 to the second power. And that's the end of that one. The last example I'm going to give you is if you have an improper fraction where the degree of the numerator is greater than or equal to the degree of the denominator, that's what makes it improper. What you have to do is first use long division, and you're going to get an answer with a remainder, and then you have to do the partial fraction decomposition on the remainder. For example, what if you're given x to the fourth over x minus 1 to the third power? Well, the degree of the numerator is more than the degree of the denominator, so we're going to have to do long division on this one. Well, in order to do long division, we're going to have to expand this x minus 1 times x minus 1 times x minus 1. And when you do that multiplication, make sure you can do this. But when you do this multiplication, you will get x to the third minus 3x squared plus 3x minus 1. And then long division on that, we're going to put x to the fourth underneath, plus 0x to the third, plus 0x squared, plus 0x plus 0 for all of those placeholders. And dividing x to the fourth time by x to the third, you're going to get just x to the first. And you know how to do long division, so I won't talk my way through this. What's going on here? 3x to the third minus 9x squared plus 9x minus 3. So what you're going to be left with is a remainder of 6x squared minus 6x plus 3, because when the degree of the resulting subtraction is less than the degree of the outside here, then you're done and that's your remainder. So your remainder is 6x squared minus 8x plus 3 all over the original x minus 1 to the third power. And that's what you're going to do partial fraction decomposition on. So since this is a linear factor repeated 3 times, we're going to have a over x minus 1 plus b over x minus 1 to the second plus c over x minus 1 to the third power. And that's going to be equal to our 6x squared minus 8x plus 3 all over x minus 1 cubed. And if you clear the denominator, you get 6x squared minus 8x plus 3 is equal to a times one of those three x minus 1's cancels, so you have x minus 1 to the second power plus b times x minus 1 to the first power plus c. It looks like if we let x equal 1, we'll get rid of everything except for c. So we have 6 minus 8 plus 3 is equal to c. And then negative 2 plus 3 is equal to 1. And then I guess I can let x equal 2. And what we would have is 24 minus 16 plus 3 is equal to a plus b plus c is 1. 24 minus 16 is 8, and 3 is 11. And if you subtract 1 from each side, you're going to get 10 is equal to a plus b. Now we need another equation with an a plus b. I guess we can let x equal negative 1. No, let's let x equal 0. So we get 3 is equal to a minus b plus c. So if you subtract 1 from each side, you're going to get 2 is equal to a minus b. So now we have our two equations with two unknowns. If we add those two together, we're going to get 12 is equal to 2a. So 6 is equal to a. And then you can back substitute in either of these. 6 minus b equals 2. And it looks like b is equal to 4. So we have 6, 4, and 1. So if we put those all together, our partial fraction decomposition combined with our long division, our answer will be x plus 3, which was the result of our long division up here. Don't forget to put that. Don't just put the partial fraction decomposition down. And then we're going to add to that, let's see, a was 6, 6 over x minus 1, b was 4 over x minus 1 to the second power. Whoops, you can't see that. And then c was 1, x minus 1 to the third power. So there's our final answer without forgetting the x minus 3. And that's it for today. We'll have lots of practice on this on Monday.